In this video, I'm going to set up a linear programming problem. So the first thing that we need to do is to define our variables, what x, y, and z represent, and determine what our objective function is. So the easiest way to do that is to go to the end of the problem. And at the end of the problem, it says, how many days should each operation operate to minimize total cost? So I now know that we are trying to minimize cost. And we're meeting requirements when the daily operating costs are $430 for Munds Park, $560 for Walnut Canyon, $450 for Snowbowl. So I'm going to let x equal the number of days for Munds Park. I'll just write MP. Let's let y be equal to the number of days for Walnut Canyon. And then if we let z be equal to the number of days, and that's the number of days that they're operating for Snowbowl. So those are my variables. Now my objective function comes from that. And the objective function is we are minimizing, so C equals, and we're given the cost. If X is the number of days that Munds Park operates, and it costs $430 per day, so 430X would be the total operating cost for Munds Park. Likewise, $560 operating costs per day for Walnut Canyon, which is Y, and $450 per day for Z days for Snowbowl. So there's my objective function. We already know we are doing a minimization problem. So now as we read the rest of the problem, we need to determine what the constraints are and whether we have a standard or a non-standard minimization problem. So let's go to the beginning of the problem. Flagstaff Timber Company has 3 logging operations at which it harvests high, medium, and low-grade timber. Munds Park operation, which we know is X, harvests 3 hectares. Don't worry about what a hectare is. It's just a unit of measure. 3 hectares of high, 4 hectares of medium, and 6 hectares of low-grade timber. Walnut Canyon operates 5 hectares of high, 3 medium, 2 low-grade. And so I kind of get the idea of what's going on here. Looks like what I'm going to have to do is I'm going to have high grade, medium grade, and low grade. And then each one of the locations is going to be harvesting some of that high, medium, and low. So kind of setting up a little table here. And so going back to Munds Park has 3 high, 4 medium, 6 low. So 3, 4, and 6. 3, 4, and 6. And Walnut Canyon has 5, 3, and 2. 5, 3, and 2. And finally, Snowbowl. And Snowbowl operations 7, 2, and 5. 7, 2, and 5. Now, last thing that we need, if these are our constraints, there has to be some kind of constraint on the high, medium, and low. And so that comes here. The company needs to harvest at least 55 hectares of high-grade timber, 88 hectares of medium-grade timber, and 57 hectares of low-grade timber. So that tells me that high-grade at least 55, so that means greater than or equal to 55. at least 88 hectares of medium, so greater than or equal to 88, and 57 for low grade. And so we just put our variables in here, X, Y, and Z, and put our little plus signs in there. And voila, we have our three constraints. So we have our objective function, and we have our three constraints. And so we already knew that our objective function was a minimization problem. And now we know that we have a standard minimization problem because all of our inequality symbols are greater than or equal to. So once you have the objective function, find your constraints, and determine what type of a problem it is, minimization, maximization, standard or non-standard, and then based on that, you solve it in the appropriate manner. All right, I hope this was helpful.